So this morning we will be looking at solid phase micro extraction. Now it is one of my favorite techniques for the GC. So I have had the pen that contains the solid phase microfiber on the end of it sat in the inlet of the GCMS. That helps clean off any absorbed nitrogen or water. The inlet is at about 150 degrees, and I just let it sit there for a few hours with the little fiber out inside the inlet, and that will burn off anything that's already absorbed in there. So to take that out, I'm just going to put the fiber back inside by moving this piece. Pulling out the pen, you can see the needle that went down inside the inlet. And if I put it up against this red box, maybe you can see the little fiber as it comes out. Yeah, it's really hard to see, okay? But it's like a very small needle inside there. And so to keep it safe, it retracts inside that metal sleeve most of the time. Now, it's one of my favorite analyses, and basically the fiber will absorb any molecules that are in the air. So we're going to look at the smelly molecules, the very, very volatile molecules that come off of our homemade lavender hydrosol. So we made this just the other day, and it's been sat in the fridge. So I took it out of the fridge, and I've been warming it up gently for about half an hour. And so there's only about a quarter full, and so the warming it up, water and all the smelly molecules have come into this headspace. So this is what it's called. It's also called Headspace Analysis. So I'm going to put the pen inside. I've constructed this thing to hold it, and then once it's in place, I stick out the little fiber, and then I'm going to time it for about 10 minutes. Okay, so it's going to sit inside the headspace where all the smelly molecules are for about 10 minutes. Now the microfiber, this particular one, is made up of polydimethyl siloxane coating, so it's very good at absorbing non-polar molecules. And also a lot of the essential oil molecules. It's very similar to the DB5 material inside the column of our oven, of our GC. But you can buy other types of fiber, and of course they are able to absorb different amounts and different molecules. So we're already affecting our results by the type of fiber that we choose. So we have chosen this one, but we also could have chosen this one here, which is polyacrylate. I'm just going to open up the box so you can see what the actual fiber looks like. Okay, so there's one in here. So this goes inside of the pen. You can get various YouTube videos to show you how to take in and take out these fibers. And again, the fiber is living inside of that retractable metal tubing. So once we've had our pen sat there for about 10 minutes, we are ready to retract the needle. Never move from A to B with your fiber out. So we're going to take our fiber, put it back inside the pen, and take it to the inlet of the GC. Now I've got the GC already ready. I've got my program, which is exactly the same as my essential oil program. Let me just put this back, and we'll go through that. So my essential oil program is this particular one here. So let's look at the oven conditions. So we start the oven at about 40 degrees, and we hold it there for a couple of minutes, and then we go at 20 degrees per minute all the way to 250. It lasts 12 and a half minutes. The inlet is at 150 degrees, and we have a flow rate of about 1 mil per minute, okay, which gives us a pressure in the inlet of 7 psi. So that's perfect. The reason I only go to 250 degrees is from experience. I know that there aren't many essential oil components that come off after 250 degrees. So there is no point going to the full 300 degrees, which our DB5 column will go to. This particular instrument over here has a chiral column in it, and I only ever run that to 200 degrees because at about 250 degrees, the chiral column will start to disintegrate, and we don't want that to happen. The DB5 column is a lot more versatile and a lot better at higher, and will withstand the higher temperatures. Okay, so that is the GC settings. Now we'll press on the mass spec settings here. And we'll look at, we have a solvent delay set for 3 minutes. We're going to actually override that. You don't need a solvent delay when you do solid phase micro extraction because there is no solvent. Things are going to be desorbed from your little microfiber, and there is no, you might get a little bit of air in there, a little bit of water. And so if we go to the mass spec settings, and we go to timed events, we can see here that we go to about 750 and the high mass region, and we start at 25. So we're not going to see water anyway. Okay, so that means we don't need to have any kind of solvent delay. Okay, so we're just about ready. So I'm going to get the instrument going by clicking on that big green button down here. I'm going to call it the actual sample, I should call it. So it's solid phase micro extraction. It is lavender, and it's Sharon and Hannah's. So that's what I'm going to call it. I'm going to go OK and run. Okay, and then at that particular point, all it's doing is checking that we are ready to run. I'm going to come over here again. Remember, retract the needle, take it over to the GC. Now watch the needle go down through the middle of the septum. Goes in very easily. I'm going to press prep run over here and wait for this light to disappear. That tells me that everything is ready. Down with the needle and press start. Okay. Now it says, do I want to override that solvent delay? This is one case and the only case. Yes, I do. Normally, solvent would be something like ethyl acetate or hexane or something like that, and we wouldn't want to see that in the mass spec, and so we just allow it to be picked up by the helium. It's very volatile, so it just goes straight through the instrument and into the mass spectrometer. Without turning the mass spectrometer on, we don't see it. We don't record that, and that's good because we would have, in a normal run, we would have like 999 to 1 of solvent to sample. Okay, so now we just wait. The 12.5 minutes, and I'll show you later what we got.